today we're going to talk about division of polynomials. And division of polynomials, we're going to have three different cases. The first case we're going to have is division when you have a monomial. Remember, a monomial is a one-term expression. So if we're dividing by monomials, I want us to make little mini problems. So I'm going to rewrite their problem because I like to write a little bit larger. So 30x cubed plus 15x squared minus 25. And what I'm going to do, when you're dividing by a monomial, that means I'm going to take that monomial and I'm going to divide it into each of the terms that are in the numerator. So what I like to do is I like to just make, in this case, you've got three terms on the bottom. So I'm going to draw a line in between those terms, and I'm going to make three little small mini problems by writing the denominator underneath each one. That way when I go through and I do my canceling with my numbers or with my variables, then it's easier for me to see what's left over instead of trying to do it one time with the one monomial written there. So I've just made three little mini problems. I'm going to take each little chunk by itself. So in this first one, 15 goes into 30 two times. I have an x cubed over an x squared, so 3 minus 2 gives me a 1. So that gives me 2x to the 1. I don't have to put the 1 there, but I'm going to just so you can see it. Alright, then I move on to the next one. It's got a plus 15 divided by 15, so that's going to be a plus 1. And then x squared divided by x squared cancels out. So I don't have any variables with the 1, so I need to put a 1 there, so I have a plus 1. Okay, then I move to the last term, and 15 and 25, 5 goes into both of those. So 5 goes into 15 3 times, 5 goes into 25 5 times. It is negative because there was a negative here, so I have a minus 5 over 3. And you'll see I don't have any x's on top. I've got an x squared on the bottom, so it's just going to stay right down there on the bottom with that 3. So now I've just divided by the monomial. And they're going to look odd because sometimes they have this last term as a fraction. You may have some fractions with your variables in the denominators in the middle, but that happens sometimes. It just depends on how the numbers and the variables work out. Now, you could have it written with a division symbol. So if I have it written like that, I rewrite it anyway because I like to have them stacked. So I'm going to just copy the problem. But I'm going to make me three little mini problems because again this has three terms in the numerator. And I'm going to divide my problem up, and I'm going to put the negative 3a to the 4th b cubed on the bottom underneath each one to make my problems just a little bit easier to see when I do the canceling. Okay. So 3 goes into 6 two times, and it's going to be negative because I have a negative in the denominator. The a to the 4's cancel, and then I've got b to the 5 over b to the 3, so 5 minus 3 would be b to the 2. Now here, these two numbers, 4 and 3 don't divide evenly. I have a negative divided by a negative, so I'm going to change that to a positive. I'm going to put my 4 on top and my 3 on the bottom. And then I've got an a cubed over an a to the 4th, so that's 3 minus 4. That gives me a to the negative 1. I'm going to take care of it in just a few minutes. And then I've got b to the 7th over b to the 3rd. 7 minus 3 would be b to the 4th. Then I'm going to move to the last one. 3 goes into 9 3 times. It's going to be negative because I have a positive divided by a negative, so minus 3 on top. Here I've got a squared over a to the 4th, so 2 minus 4 is a negative 2, so I have an a to the negative 2. And then b cubed over b cubed just cancels out. Now remember, we cannot leave our answers with negative exponents, so these a to the negative 1 and the a to the negative 2, I need to take care of those. So 2b squared is fine, plus, remember 4's on top, 3's on the bottom. Now b to the 4th was just fine. He has a positive exponent, so he's going to stay up here with the 4. The a to the negative 1 is going to have to come down here to be with the 3 and be a to the 1 minus. In this last term, the 3 is just fine, but the a to the negative 2 needs to come to the bottom and be an a squared. So as I said, they're going to look a little odd when you do this division. It doesn't always come out to be just nice and neat. So we'll just kind of have to pay attention. So in order to fill in these blanks, to divide each polynomial, or to divide a polynomial by a monomial, divide each individual term in the polynomial by the monomial, and then simplify each term. If a, b, and c are polynomials, then and c is not equal to 0, a plus b over c is the same thing as a over c plus b over c. And you see they're making the little mini chunks like I did. Okay, let's do this last one at the bottom. 25 c to the 5th d minus 10 c to the 4th d plus c squared d. And then I'm dividing by positive 5c cubed d. Okay, 5 goes into 25 5 times. C to the 5th over c cubed gives me c squared, and then my d's cancel, so no d's left. Alright, and then the second term, 5 goes into 10 2 times, and it's a minus because I have a minus 10 up there. C to the 4th over c cubed, 4 minus 3 is 1, so I have a c to the 1. D's cancel again. Alright, in the last term, I don't have a number to cancel with that 5, so 5 is going to stay on the bottom. C squared over c cubed, 2 minus 3 gives me a negative 1, so I'm going to have c to the negative 1. I'm going to take care of him in a minute. And did the d's cancel? D's canceled in every single one of those. That's interesting. Okay, so the last thing I can do is I can move that 5c squared minus 2c plus. Now, c to the negative 1 needs to come down here with the 5. So 5c to the 1. And since I took everything from the top, you need to have a 1 on top. So that's 5c squared minus 2c plus 1 over 5c to the 1. I kind of scrunched that in there. It's kind of hard to see. That is the answer. Okay, so now the next kind we can have are long division problems. Okay? And in long division problems, here's some things you need to know. First of all, this is dividing by a binomial. So we're dividing and it could be bigger than a binomial, so I'm going to put you're dividing by a polynomial. The ones we do are going to be all binomials, but in a later math class you could have a longer polynomial to divide by. So we're dividing by a polynomial. We need to make sure that we have descending order. For all, so that means descending order in the numerator and descending order in the denominator. And then if we are missing degrees, we need to use 0 as a placeholder. Let me explain what that means. In this problem, I've got 4x cubed plus 7x squared minus 3 divided by x minus 2. In the 4x cubed plus 7x minus 3, that is in descending order. But if I start counting with my degrees, I've got a cubed, a squared, I'm missing an x to the 1. So I'm missing an x to the 1. So I'm going to have to use a place filler in just a second when I do this division. Alright, so I want us to think back to when we were a kid and we did long division. And here's an example. You had 43, let's say it goes into 5,281. Now I want us to think back to the process of when we did long division. Your first step was to take 43, it won't go into 5, so we take 43 into 52. And that goes one time, and we would line up the 1 with the 2 because we were taking 43 into 52. Then, do you remember what we would do next? We would multiply. 1 times 43 is 43. Then we would subtract off, and we would say 52 minus 43 is going to be 9. And then we would bring down the next number, which is an 8, and we would start over. 43 goes into 98 2 times. 2 times 43 is going to give me 86. Subtract that off. 98 minus 86 gives me 12. Bring down the 1. 43 goes into 121 2 times. 2 times 43 again is 86. It wouldn't go 3 times. I tried it before I did this video. We have 35 left over, and remember 35 then was my remainder. And I don't know about you, but I can remember writing my remainder as just R35 or just as a remainder. But there is a way to write the remainder that you may not remember, but the way you write the remainder is you put the 35 over what you were dividing by, which would be the 43. Okay? So the remainder came up here and looks like that. So when we do long division with these polynomials, we're going to follow that same process. And you may have to watch this video a couple of times to get this, but it may just take a couple of times. So I'm going to have x minus 2 on the outside because that's what I'm dividing by, and then underneath I'm going to have 4x cubed plus 7x squared plus 0x, remember I have to have a place filler, minus 3. I'm missing that x to the 1, so that's why I put the 0x in there. So anytime you need a place filler, put 0 and then whatever degree it's supposed to be for the variable. Okay, now let's follow. This time we're just looking at really x into each of these as we go, like we did 43 into 52. So x goes into 4x cubed. Well, I like to think of it this way. X times what equals 4x cubed? Well, to get x to be an x cubed, I'd have to multiply by x squared, and to get a 4 into that, I'd have to multiply by 4. So x times 4x squared equals 4x cubed. So x goes into 4x cubed, 4x squared times. Now line that up with the x squared term that's underneath. So I'm lining it up with the 7x squared. Now, after we had a number on top, we would multiply in long division. So we're going to multiply 4x squared times x gives me 4x cubed. 4x squared times a minus 2 gives me negative 8x squared. And we've got to subtract off. So subtract off, draw some parentheses when you subtract off. Because remember, if we have a negative in front of a parentheses, that comes in here and changes these signs like that. So the 4x cubed becomes a negative, the 8x squared becomes a positive. Okay, so let's add straight down. The 4x cubes would cancel each other out. 7x squared plus 8x squared would give me 15x squared. Now bring down the next term, which is going to be our 0x. And then we start again. So x goes into 15x squared. So x times blank would give me 15x squared. Well, I'm going to have a 15 in there. And then to get x to be an x squared, I'd have to multiply by x. So I'm going to put a 15x above my 0x. Multiply through. 15x times x is 15x squared. 15 times a negative 2, or 15x times a negative 2 is a minus 30x. We need to subtract off. So that's going to change my signs to a negative and a positive. Add straight down, or subtract straight down. So 15x minus 15x squared would cancel. 0 plus 30x would be 30x. Bring down a minus 3. Start again. X goes into 30x, so x times blank equals 30x. And this time it's just the number 30, so a plus 30. And lining it up helps me see what I'm looking for next. I could see I already had an x term, so I knew I was looking for a constant term to go above that negative 3. Okay, multiply out. 30 times x is 30x. 30 times a negative 2 is a negative 60. Subtract off. So let's change those signs. And then let's do our subtraction. So the 30s cancel. Negative 3 plus 60 gives me positive 57. That is my remainder. Now, to write your solution, it's this part that we have at the top when we did the division. 4x squared plus 15x plus 30, and that's a positive 57, so it's plus 57 over what I was dividing by, which in this case was x minus 2. And that's the final answer for that. These problems can be kind of lengthy when you're doing long division. So let's do another one, and then I'm going to show you another way to do these. Okay, so let's do this one. We've got 2y plus 1, that's what we're dividing by. But remember, we have to have descending order, so this is 2y cubed plus 5y squared. I'm missing a y term again, and then I've got the negative y. Be very careful with that in case they try to throw you in one that is not in descending order. You need to put it in descending order. So I'm going to have 2y plus 1 divided into 2y cubed plus 5y squared plus 0y minus 1. Okay, so let's follow the same process. 2y goes into 2y cubed, so 2y times blank equals 2y cubed. Well, I already have the 2. Y to a y cubed would just be y squared. So I'm lining it up with the 5y squared. So y squared. Let's multiply through. Y squared times 2y squared is 2y cubed. Y squared times 1 is a plus y squared. We're going to subtract off, so I'm going to change those signs. The negative and the negative. 2y cubed would cancel. 5y squared minus 1y squared is 4y squared plus 0y. Now, if I had gotten down here and I had had a 5y squared, 2 doesn't go into 5 evenly. You're not going to have it in your homework that are going to be odd fractions up here when you do your division. So if you had come out with a number that 2 didn't go into, then go back and check and make sure you did this subtraction correctly, because I'm not giving you ones that are that hard. So now I need to start over. So 2y times blank equals 4y squared. So 2 times 2 is 4. Y to a y squared I need to multiply by y. So plus 2y. So 2y times 2y is 4y squared. 2y times a 1 is a plus 2y. Subtract off, so that's going to change those signs to a negative and a negative. 4y squareds cancel. 0 minus 2y is a minus 2y. Bring down the negative 1. 2y goes into negative 2y, so 2y times blank would equal negative 2y. So we're just multiplying by negative 1. So minus 1. So now multiply, negative 1 times 2y is negative 2y. Negative 1 times a positive 1 is negative 1. Subtract off. Changes these signs. And 2y plus 2y, negative 2y plus 2y would cancel. Negative 1 plus 1 would cancel. So I have a 0 for a remainder. So in this one, I'm not going to have to write that remainder fraction at the end because I have 0 for a remainder. So my answer is y squared plus 2y minus 1. And that's how you do long division. So now I'm going to skip to, I'm going to skip to this page right here, where we are going to do a procedure called synthetic division. Actually, I'm going to skip this page too. I'm going to go to the next to last page, because here we go. We're going to do synthetic division. Alright, so here's some things about synthetic division. Some of you may remember doing this if you ever had an algebra class in high school. You may have done synthetic division. So synthetic division uses a chart. And in the chart, you use coefficients. And so we need to remember what our coefficients are, and coefficients are the numbers in front of our variables. And then you can only use synthetic division if you have a 1x to the 1 as your divisor. If you don't have a 1x to the 1, then you have to use long division. So like the one I did previously that had the 2x, it had an x to the 1, but it had a 2 in front of it. I couldn't have used synthetic division on that one. I would have had to have used long division. So again, it still has to be in descending order. So I have an x cubed, an x squared. I'm missing an x to the 1 term. So this is really going to be 4x cubed plus 7x squared plus 0x minus 3 when I put my place filler in here. Alright, so synthetic division uses a chart, and the way the chart looks like this: you have a little corner box, and then we come down and take a little space and then draw a line. Okay, in the corner box goes the number, the opposite of the number you are dividing by. So if I'm dividing by -2, the opposite of -2 is 2. So you have to use the opposite sign of that number. That's key. You have to use the opposite sign. Now, out beside the corner box are going to go the coefficients of what would be the numerator. So these coefficients, no x's in there, just the coefficients. So 4, 7, 0, and -3. And we don't change the signs on these. Now, what comes next is just the process of synthetic division. The first step is to bring down that first number, 4. Okay, in this case it's a 4. Then we are going to multiply. 4 times 2 is 8. The 8 goes under the next number. Add straight down. 7 plus 8 is 15. Start over. Multiply 15 times 2. That gets me 30. 30 goes under the next number, which is 0. 0 plus 30 is 30. Start again. 30 times 2 is 60. 60 goes under the last number. -3 plus 60 is 57. Okay, so that is my remainder. We'll take care of him when we write our answer. The numbers that I get out here are the coefficients of my answer. Remember, I started with the coefficients to write my problem, if I can get my pen to write. These are the coefficients of my answer. So when you write an answer, use 1 degree less. So my original problem started with a 4x cubed. So in this one I need to start with an x squared. And then these are my coefficients. So that's going to be 4x squared. Then the next degree would be x to the 1, so plus 15x to the 1. Now I don't have any variable for the 30, and then my remainder, 57, still goes over what I was dividing by, x minus 2. And if you'll look back, we did this exact same problem with long division and got the exact same answer. So that's synthetic division. It's a little process, and I know the first time you see it, it may look difficult, but it gets easier. So synthetic division is considered a shortcut because it uses only the coefficients. It's important to check that the divisor is the form of x plus a, or it could be x minus a, but it has to be a binomial. To use synthetic division, the variable of the divisor must be of the first degree, and its coefficient must be a 1. So you have to use those. Alright, so now I'm going to do this next one a little bit quicker. Here I've got t cubed, I'm missing a 0t squared, I'm missing a 0t, and then I've got a 64. I'm dividing by t plus 4, so change that positive 4 to a negative, change its sign, and then my coefficients are 1, 0, 0, 64. Bring down the 1. Negative 1 times 4 is negative 4. 0 minus 4 is negative 4. Negative 4 times negative 4 is positive 16. 0 plus 16 is 16. 16 times a negative 4 is a negative 64. 64 minus 64 is 0. So there's no remainder on this one because I had a 0. So my original problem started with a t cubed. My answer is going to start with t squared. So a 1t squared minus a 4t would be the next degree, plus 16. Boom, there I'm done. It's that quick when you have synthetic division. Let's do one more. Now on this one, it's got an example on the side, which is really nice. So let's do one more and then we're done for the day. We have z plus 2, so I'm going to divide by 2. Now in this case, I'm going from a 2 to a 1 to a constant, so I'm not missing any degree, so I don't have to worry about place fillers. So I put in my coefficients. Start your synthetic division. Bring down the 3. 3 times negative 2 is negative 6. 1 minus 6 is negative 5. Negative 5 times negative 2 is a positive 10. Negative 5 plus 10 is positive 5. So I started with a z squared. My answer will start with z. So 3z minus 5. And then this last 5 is my remainder. 5 over what I was dividing by, which was the z plus 2. Remember to go back to your original, what you were dividing by, not what you put in your chart. So there's my answer. That's synthetic division. We've done all of division now. I hope you have a wonderful day.